Right, now we're working through these last few examples on regions in the Argand plane, and the first of those is example number 4, as we can see here, and that is to shade the region of the Argand plane such that argz is between these two angles, negative pi on 3 and pi on 6, and then you've got this funny symbol here which means intersection, and this region here which is the absolute value, or the modulus of z minus 1 is less than 3. What we need to do is look at these regions separately to see what they are, and this intersection part means we want to shade the region that holds true for both of these at the same time. So let's first consider this part here. Okay, let's first consider that one. Now this, remember, with argz is going to represent a ray. Now because it's just z and we haven't got any translations in there, it's going to be from the origin. So if we're just going to draw in here our plane, whoops, there should be mz and real z. Now our angles that we have is negative pi on 3. Okay, so pi on 3 is around about a 60-degree angle, but because it's negative, we're going to come down here. Okay, so come down right about there, and then we've got this angle here, which is pi on 6. It's positive, and pi on 6 is around about 30 degrees. Okay, so we should find that these two are pretty well, they will be 90 degrees to one another. Okay, so we've got here, this is pi on 6, and this one's pi on 3. Okay, now notice I've had to draw these with solid lines because they're less than or equal to. Okay, so the rays themselves, the lines themselves, are going to be included in the answer. Now, the shaded region is going to be above our negative angle here, and less than or below our angle pi on 6 here. So this region, this is the region in here that we would shade if this was our only part of the question. I'm just going to hold off shading for the moment because I want to consider what this is here. Alright, I might just do that in green just so that we can see a little bit easier. Now you remember this gives a circle. Okay, now it's going to have to be a dotted circle because it's less than 3. The radius will be 3 units, and our centre is going to, well, let's just translate it from the origin 1 unit to the right. So if we consider perhaps this part here being 1, then that will be our centre, and it's 3 units as our radius. So 1, 2, and 3 is out here. I might have to extend things a little bit here. Okay, so extend that out a bit more. Extend this one out a bit more here. Might just going to have to get rid of that. And extend that out. So that's real Z. Now, 1, 2, 3. Okay, so 3 units, that's our centre there. So 1, 2, 3 units is our radius. So we want to come down here. 1, 2, 3. There. So that's our circle. That's our centre. So we probably should just put a little mark there to just designate that's the centre of the circle. And we can see here with that there, that indicates that we've got our radius correct anyway. And our shaded region is less than 3, so it's going to be all this area in there as our answer. Okay. Let's move on and have a look at our next example. Example 5. Okay, so in this particular example, we don't have to draw the region, but work out what the region represents. So, define the set of complex numbers represented below. Well, I'm not going to draw it here, it's over there. So we're going to have a look at this one here. Now we've got circles. So we can see here this inner circle has a centre at 1, 1, or let's just write it here. Inner circle has a centre at 1 plus I. Okay, 1 on the real and 1 I on the imaginary. That's our centre, and a radius of 1 unit. Okay, so how do we represent that? Well, we would represent it, because it is translated 1 unit to the right and 1 unit up. It's going to be Z minus 1 minus I. And that's all in these absolute value symbols. Our radius is 1, so we have a 1 there. But the question is, what inequality sign do we use? Well, it's dotted here. So we know it's either going to be less than or equal, or less than or greater than, not no equals there at all. Okay, but because it's shaded on the outside of the circle, it's greater than. Okay, so it's greater than 1. And then we've got our outer circle, which we're going to consider. The centre, we can see, is the same. These are concentric circles, so it's also 1 plus I, and the radius in this case is not so easy to see by just measuring right or up and down. What we need to do though is we know what the centre is here, and we know that it passes through 2 on the y-axis. Okay, so if we just going to draw here, that is our y-axis, 2 there and 1 and then 0, and we know that it passes through here, and we know that that's the centre. So what we can do is we can draw a right angle triangle, and we can work out the radius here because we've got these two perpendicular sides. We know what their lengths are, 1 unit and 1 unit, so the radius from that we can see is going to be the square root of 2, just using Pythagorean theorem. Alright, so our radius then is root 2, which means we can write this one in the same way, z minus 1 minus I in absolute value symbols. Now it is less than, it is because it is inside that circle, that larger circle, so it's going to be less than, but it also is going to be equal to, because it's a solid line, solid curve. and that's less than or equal to the square root of 2. So with this region here, it's both of these holding simultaneously. Alright, so there's a couple of ways we could write that. We could write it in the same way as this first one. So our solution could be written as z minus 1 minus I greater than 1 in those braces, just to show that's the set intersection symbol, and then z minus 1 minus I less than or equal to square root of 2. Or we could write it in this way, just writing our z minus 1 minus I once only. Now we know that it's greater than 1, so we can put the 1 less than that, and that's less than or equal to the square root of 2. Okay, so strictly speaking, if we need to have in braces, which represents the set, it's a set of complex numbers z such that, and this is our rule, okay, the modulus of z minus I minus 1 minus I is between 1 and the square root of 2, and or particularly it's less, 1 is less than it, and it's less than or equal to the square root of 2. It's hard to say these things out loud, but we can write them quite simply. Okay. Okay, so there's not enough time to go through example 6, so we'll stop this video here and continue example 6 in the next video.